Hi, here is integration by parts practice problems with indefinite integrals part 3. First, I understand that there's tons of tutorials out there for the same thing. Therefore, if I can't be a help, I'd highly recommend you checking out Professor Leonard, who is an extraordinary supplement to my calculus classes, Professor Dave Explains, the organic chemistry tutor Patrick JMT, and such, and I'll probably share links in the description below. I am fully aware that I may not be able to get through to every single person watching this. I'm definitely not proclaiming that I discovered a breakthrough in teaching, nor am I the best tutor in the world. I just simply want to help out the best I possibly can. Teaching is my passion. So let's get started. What we have here is the integral of x dx. Now we know the derivative of ln of x, the natural log of x, which is 1 over x. But the integral of ln of x is a little bit more complicated than it looks. So we're going to use integration by parts here. And with integration by parts, you really want to look for a product. The formula, which I derived in a previous tutorial, goes like this. The integral of uv or udv equals uv minus the integral of v du. So this integral of u dv is right here. We just have to pick which one's u and which one's dv. I said there has to be a product, and it doesn't seem apparent at first that this is a product, but it is. Ln of x times 1. Okay, it's ln of x times 1 dx, essentially. Now, we need to find, u needs to be something we could differentiate easily. dv has to be something that we could integrate easily. Well, ln of x, we know the derivative, but to integrate it, I mean, that's the whole point of this problem right here. So, therefore, we are going to let u equal ln of x, and we're going to set dv equaling to what's left over, okay, which is just dx. And then we differentiate u, we call it du. Du equals 1 over x dx, and v is the integral of 1 dx, and the integral of that would just simply be x. Now this is how I really recommend you setting it up. That way it would be easy to see our uv minus the integral of v du. You just draw an arrow, u times v, and you multiply these two, and you subtract it by the integral of v du, like that. So when we do that, our integral of u dv is the integral of ln of x dx, and that's going to equal uv, and we set u equaling to ln of x, and we set v equaling to x. Therefore, this is going to equal uv, okay, or vu, it's commutative, minus the integral of v du, which is x over x dx. And you could probably see already that x over x dx, well, the x's are going to cancel, and you're just left with dx. Therefore, our v du is simply dx. Okay, and then we just solve from there. We have x ln of x minus the integral of dx, which is just x, and plus c, since we're done integrating and it's an indefinite integral. Okay, that's the valid answer. Some people factor out the x, and we're left with this. But you must not forget the constant of integration right there. Okay, so that's one practice problem. Now let's go on to the next one. The integral of z squared e to the z dz. Okay, same thing. We want our u to be something that we could differentiate easily, and our dv being something that we could integrate easily. We could differentiate and integrate both of these easily. So which one should we choose? We should always choose the polynomial, and as I do this problem, I'll explain more why later, but let's let u equal z squared, and then our dv is going to be everything left over. dv equals e z dz. Okay, so our du is going to be the derivative of that, so it's 2z dz, and v equals, well, the integral of e to the z is just e to the z. It's like the derivative of e to the x is e to the x, and the integral of e to the x is e to the x, same thing. Now we're going to do this again. So this is the integral of u dv, and it's going to be subtracted by u v minus the integral of v du. Okay, so we could say that this is equal to uv, okay, u times v minus the integral of v du, okay, that's 2z ez dz. Okay, so the reason why we want polynomials for our u in lieu of having it for our dv is because notice when we differentiate polynomials, the exponent decreases by 1 right here. Okay, but if we were integrating polynomials, the exponent would keep on getting bigger and bigger and bigger, and that's totally the antithesis, the opposite of what we want. Notice that in our integrand, we have 2z to the first, but we would have probably like z cubed or something like that if we chose to integrate z squared. In other words, the integrand would get more and more like unsolvable. We want to have our exponent moving down or going downwards. So notice we have another product here, so we have to do integration by parts again. Yeah, some calculus 2 integration by parts problem has multiple integration by parts in one problem. That's just what makes it fun. So we pull out the constant integral z ez dz. Okay, so so we're going to let our u equal our polynomial, which is z, and our dv will be what's left over, e to the z dz. And I really hope I'm not making you dizzy. That's not what I want. Du equals the derivative of z, okay, which is just going to be 1 dz. Okay, and then v equals the integral of e to the z, which is just e to the z. And now we do this again. You don't have to draw the arrows, I'm just for teaching purposes. So this stays the same, of course. So z squared e to the z minus 2, but a big parentheses here, because when we do this, when we do uv minus v du, that would just be the answer to this, and this is multiplied to 2. So it's going to be 2 times uv, which is z ez, okay, minus the integral of v du. Whenever doing these problems, first learning it for the first time, it's good to go slow and make sure that you grasp it instead of doing it fast and forgetting more of it later. So then that's going to equal z squared ez minus 2z ez. Now I'm just distributing the 2. That negative 2 times negative 1 is going to be a positive 2. Plus 2. Now the integral of e to the z is easy, and it is as easy as it sounds, plus c, don't forget that. Okay, and that is a valid answer. Some people could factor out the EZ. Okay. And get that. Very easy to do. Okay, so of course it does take practice, perseverance, patience. I understand that. Whatever it is, whatever your passion is, whatever your major is, just keep pursuing it if it's in your heart. And just don't give up and just use perseverance and practice. So, and have a nice day.